Welcome to Brain Vision.
Let's do this chemistry problem about polyprotic acids. And before I get started, I recommend that you pause the video and do the question yourselves, just to see if you fully understand the topic. So, what are we given? We are given that the concentration of H3CO3 is 0.125 molarity. And because this acid has two hydrogens, we know that there's going to be two Kas, right? Two acid dissociation constants. And in that case, let's write it out. H2CO3 so that would be a Ka1. This information should usually be given to you in the question, or you can easily search it up online. And it's also important to write out the acid dissociation constant or equation so that we can understand what we're doing. And in this case, we would assume that this second acid dissociation constant here is negligible, so we wouldn't use it. It's because it's too small. So we would just use Ka1, the first acid dissociation constant. And then from there we can because we don't know the concentrations of the hydronium ion and HCO3 minus. Then we can rearrange that. And then you just square root it, and x should equal, using my calculator, I got that x is the concentration of the hydronium ion, right? And that is 2.5 molarity, and obviously easily we can calculate the pH by doing minus log of that concentration. And that should be 3.63. Now moving on to part B, so we are given 0.125 molarity of H3C6H5O7, right? So in this case, we would have three different acid dissociation constants, which would be and we would assume that Ka2 and Ka3 are negligible, so we would just ignore them and we would focus our attention on the first one only. Maybe I'll write down the equation as well, the chemical equation for each Ka. Or we can write that as H3O plus. This would correspond to the first Ka. Also correspond to the second Ka. And then the third equation. that will correspond to the third acid dissociation constant. And we can do the same thing as we did before. So we would just do Ka or 7, the first Ka, right? Okay. And we would be able to and X should be equal to right, and then we can find the pH. I just do minus log of that, and that should give you 2.0. And I'll just round it to 2.02. And always after finding the pH, do a logic check. Does the fact that the pH being so low make sense? Does it make sense that the pH being 2 is true? And yes, it would be true because citric acid or H3C6H5O7 is a very strong acid, like polyprotic acids are very strong acids. So that means if they were put in a solution, the solution would be pretty acidic. So it checks out.